Hi, this is Miss M. Brinda, working as an assistant professor in the Department of Electronics and Instrumentation Engineering in SNS College of Technology. Now we are going to see about the case study on flow meters. There are different types of flow meters and there are different types of methods of flow measurement can be done. Here we are going to see how the digital hydraulic bench, by using this digital hydraulic bench, how the flow measurement is done. Here, first of all, there are, as I said, there will be various type of flow measurement methods are done. Normally, in laboratory, students will be measuring the flow using a venturi meter, or it may be a orifice plate meter or a rotometer. These are the devices in our laboratory students will be using for measuring the flow. There, the Bernoulli's equation will be working for each meter. Students find and compare the head losses for each and every meter. They also find the losses in a rapid enlargement and a 90-degree elbow. Now we'll be seeing the challenges that is faced while using these flow measurement methods. In laboratories, normally it requires liters of water supply every time. In order to restrict the consumption of water, it is mandatory to we should monitor the usage. So it is also to mandatory to recycle and reuse the water to the maximum possible extent as per the norms of Central Pollution Control Board. So these are the challenges will be faced while we are using the flow measurement in laboratories. When we are using the flow measurement or when we are measuring the flow, we will be facing these type of challenges. So for these challenges, Techumens gave a solution for it. It gave a flow measurement apparatus which is used for the typical method of measuring the flow of an essentially incompressible fluid, that is a water. It also shows the application of Bernoulli's equation. So it gives an apparatus which gives a solution for those challenges that is faced in a laboratory while measuring the flow. As you can able to see the diagram of the digital hydraulic bench shown here. It is a mobile and it is a self-contained bench with recirculating water supply. First challenge it rectifies, that is here the water supply challenge is rectified, that is here the water supply can be recirculated. Also it provides the water at different flow rates so that it can be able to direct to different experiments, and it also includes the digital flow display. As the flow display is in digital form, we can able to do the accurate measurements. That is a flow display for hydraulic and fluid mechanic experiments. As also here there are the key specification for this digital hydraulic bench are also mentioned here. That is, as I have said earlier, there is a digital flow display and the resolution is varies from 0.001 to 1, and for minimum 0.1 to 1 liter minimum to 1 resolution. And also it is an electronic flow meter. It is made up of fiberglass and the capacity of this bench is 160. Now we will be seeing the main key features of digital hydraulic bench. A digital hydraulic bench is an electronic flow meter. It consists of a digital display which helps us to measure the measurements very quickly and very accurately. And it is made up of fiberglass. As it is made up of fiberglass, it will be strengthened and it will be easier for transportation, and it is used for longer life. It consists of lockable wheels for mobility with stability. You can see at the top there is a flat top to hold the experiment modules, which is from Techumens fluid mechanisms. And it is a self-contained with recirculating water circuit is there. It doesn't need external water supply, and which in turn it saves the main water, right? And it consists of a pump which prevents the thermal overload protection. Here you can able to see the digital hydraulic bench. It supplies a controlled flow of water to a wide variety of laboratory experiment modules. The body of the bench forms a reservoir of the sump tank with a submersible pump. As we have done in our laboratories, the flow measurement can be done, or flow measurement is done with a venturi meter or orifice meter or a rotometer. For that we need a controlled flow of meter. In that cases we will be using the digital hydraulic bench can be used for controlled supply of water so that the water wastage can be reduced. Once it has been filled, the bench needs no external water supply. That is, until then, the sump, as there is a sump, until the sump gets filled, we need an external supply. Once it gets filled, there is no need of external supply. Then as you can able to see there, the top of the bench provides a working space. This will be holding one of the choice of the experiment modules from Techupman's fluid mechanics range. If in the case of larger experiments are there, it usually stand next to the bench. Here spilled and excess water will be collected by the rim around the top. You can able to see the rim around the top which will be collecting the waters that is spilled or in case of excess water. And the trough in the top works with a removable drain wall to trap a small volume of water. It also catches the discharge water from one experiments in the fluid mechanics range. You can also able to see the hand operated control valve which helps for the flow rate from the pump, which can be the flow rate can be adjust from the pump. And you can also see an electrical box on the side of the bench. It includes a pump switch, circuit protection and a digital display of flow. There are 4 lockable wheels will be there, which allows the user to move the bench around the classroom or around the laboratory where the experiments are done. Here the 2 wheels have foot-printed locks to hold the bench in position. For this, as when we are measuring the flow, the measurement should be inaccurate, right? So to the measurement, we need the measurement inaccurate. The table should be in a position so that it should not affect the accuracy. So the 2 wheels are foot operated locks to hold a bench in position, so stability will be there. A side gauge is available at the lower side of the bench, which allows the user to check the water level inside the tank. It is an electronic flow meter. It will be measuring the outlet flow from the submersible pump. The flow meter will be providing the signals to the digital display to show the flow rate. Here the viewing angle of the display allows the user to see it clearly from a normal standing position. So we can by this use of digital hydraulic bench, we can overcome the challenges when we are measuring the flow. Here some of the experiment modules that can be done with the help of bench mounting and freestanding. Here you can see a bench mounting hydraulic canch and freestanding hydraulic bench. Venturi meter, discharge over a notch, friction locks in a pipe, flow measurement. These are the experiments can be done with the help of a bench mounting hydraulic canch, and losses in piping system. In those things they can be freestanding a hydraulic bench can be used. Now here you can able to see the Techupman's digital hydraulic bench apparatus, which is used for it is a mobile self-contained bench with recirculating water supply. This type of digital hydraulic bench can be connected with any type of flow meters where the flow measurement can be done. Here you can able to see the digital display which measures the volume of flow per seconds or per minute. As it is in digital display, it is easier to measure, and measurement can be done very quickly. Here you can see a gauge that shows the amount of water in the tank. A hand operated valve is used to control the flow rate of water. Here there is a reservoir so that the water can be filled and it can be used whenever it is required. As we have seen, it is movable. There will be four lockable wheels are there. With the help of that, we can move the table where it is to be located. As the flow measurement can be done by this, and also the height can be adjusted as shown here. According to our observation height, we can able to change the height. In this case study, we have seen how the digital hydraulic bench gave a solution for the flow meters that is used in our laboratories. That is the challenges that are faced in our laboratories while taking a flow measurement or while using venturi meter, orifice meter or rotometer. Here through this digital display, we can control the flow of water. Also, we can able to reduce the consumption of water. These are the references I have used to prepare this case study. Thank you for those people, and thank you once again. Stay home, stay safe.